Welcome to all of you. Dear students, previous lecture we had discussed about algebra and trigonometry syllabus. Today we start the first chapter, matrices. Matrix algebra has at least two advantages. First is reduce complicated system of equation to simple expression, and second is adaptable to systematic method of mathematical treatment and well suitable to computers. These are the two mainly advantages of the matrices. So students, what is meant by matrix? See the definition. A matrix is a set of group of number arranged in a square of rectangular array enclosed by two brackets. So properties, first is specify number of row and specify number of column. Two numbers row and column describe the dimension or size of the matrix. For example, this is a 3 by 3 matrix, and second is example 2 by 4 matrix. That means 2 rows and 4 columns in this matrix. And last is 1 by 2 matrix. That means only one row and second is column. How many column? 2 columns. A matrix is denoted by bold capital letter. Always, and the element within the matrix is denoted by lowercase is letter. For example, the matrix is denoted by capital letters A, B, C, D, X, Y, Z, any letters with elements is Aij. This is a small letter. See, A is M by N matrix. It is denoted by I goes to 1 to from and J goes to 1 to N. That means M is 1 to M and N is 1 to N. These are the elements. Types of matrices. First is column matrix or vectors. The number of rows may be any integer, but the number of column is always 1. That means any matrix in which matrix is only one column, that is known as column matrix. Second, row matrices. In this matrix only one row, order is only one row, any number of column but only one row is known as a row matrix. Next, rectangular matrix. Repeat the definition of matrices. This is the first example of second example and third example. This is the element and this matrix is order. This is the first row, only one row, and how many column? 2 column. That's why this matrix is order 1 by 2. Second example is first row 4 2, second row is -3 0, and first column 4 -3 and second column is 2 0. That's why in this matrix of order 2 by 2. Also this matrix is order 2 by 2. See, this is a number of rows is equal to number of column. That's why this matrix is 3 by 3. First row, first, second row, third row, first column, second column and third column. This matrix is order 3 by 3. Second example is, see, this matrix only first row and second row. In this matrix only 2 row and how many column? First column, second column, third column and fourth column. That's why in this matrix is order 2 by 4. And lastly, only one row and 2 column in this matrix. That's why this matrix is order 1 by 2. See, this is a general matrix form. That means A11, this is a element. All these are element, and this is matrix always denoted by capital letter. A matrix is denoted by a bold capital letter, and the element within the matrix are denoted by lower cases letter. Matrix is denoted by always capital letter A, B, C or X, Y, Z, and elements always small letter A, I, J. I means 1 to M and J means 1 to N. This matrix is denoted by, in this matrix is denoted by A of, this is order M by N is equal to first row, second row up to nth row, first column, second column up to nth column. That's why in this matrix of order M by N. Now type of matrices, first column matrix or vector. In this matrix only one column. See how many rows? First, second, 3 rows, and column is only one. Also in this matrix only one column. Also this is a only one column. That's why in this matrix the number of rows may be any integer, but the number of column is always 1. Second types of matrix. Next definition, row matrix. In this matrix only one row, but only one row. This is a, in this matrix only one row. And how many column? First column, second and third column. That's why only one row. This matrix is order 1 by 3, and this matrix is order 1 by 4, and this matrix is order 1 by n. Next definition, rectangular matrix. See the definition, contain more than one element and number of rows is not equal to number of columns. Dear students, in this matrix how many rows and how many columns? First row, second row, third row and fourth row, and first column, second column. That's why this matrix is order 4 by 2, and this matrix is order 2 by 5 column and 2 row. That's why this matrix M does not equal to N. This is order does not equal to equal. That's why number of row is not equal to number of column is known as the rectangular matrix. Next, square matrix. The number of rows is equal to number of column is known as the square matrix. For example, a matrix in which number of rows is equal to number of column is known as a square matrix. This matrix is order 2 by 2, 2 row and 2 column. Order is 2 by 2, and this matrix is order 3 by 3. Number of rows is 3 and number of column is 3. That's why the square matrix. The principal or main diagonal of a square matrix is composed of all elements Aij, for which I is equal to j. Next definition, diagonal matrix. A matrix where all the elements are 0 except those on a main diagonal. That means in this matrix non-diagonal element are 0. Non-diagonal elements means A11, A22, A33. This is a diagonal elements, and other is a non-diagonal element. Second matrix is order 4 by 4. A11 A22, A33, A44, all element is a diagonal elements and other elements is a non-diagonal elements. That's why in this matrix non-diagonal elements are 0. That is, here Aij is equal to 0 for all I does not equal to j, and Aij does not equal to 0 for some all I is equal to j. Next definition: unit or identified matrix. A diagonal matrix with 1 on the main diagonal. In this matrix, students, in this matrix, diagonal element always 1. See, this is a diagonal element, A11, A22, A33, A44. This is a diagonal element, and other element are 0. The condition is, unit matrix is, these diagonal elements are always 1, and non-diagonal elements are 0. In this matrix of order 4 by 4. First, this matrix is a square matrix and diagonal element is 1 and non-diagonal elements are 0. That is, Aij is equal to 0 for all I does not equal to j, and Aij is equal to 1 for some all I is equal to j.